Hi. We're in this session going to be looking at what happens when you combine a risky and a risk-free investment. Put some of your money in the risky investment, put some of your money in the risk-free investment. And we're going to be working from the class notes that are titled Risk and Risk Aversion Part 2. So it might be very helpful for you to be kind of following along in those notes. And hopefully you've even read those notes prior to taking a look at that here. So let me bring this out, these notes for us to be able to look at together here. And what we see is, first of all, the generic formula for the expected return on a portfolio. Okay, so the expected return on a portfolio is really easy. It's a weighted average of the expected returns on each of the assets that make up the portfolio, with the weights being what proportion or what percentage of your money is invested in each of those assets. So W1 is the weight in asset one. It's what proportion of your money is invested in asset one. W2 is the weight on asset two. It's what proportion of your money is invested in asset two, and so forth. And whenever we have a weighted average, the weights have to add up to 1. So here's our formula, okay, for the expected return of a portfolio. It's going to be the weight on asset one times the expected return on asset one, plus the weight on asset two times the expected return on asset two, plus the weight on asset three times the expected return on asset three, plus blah, 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 forever and ever for as many assets as we have in that portfolio. If we have 100 assets in the portfolio, it's the same thing. The last part is going to be the weight on asset 100 times the expected return on asset 100. Again, weights always have to add up to 1. So if you have 30% of your money into asset one, then the weight on asset one is 0.3. If you got 25% of your money into asset two, the weight on asset two is going to be 0.25, etc. Weights always have to add up to 1. Well, now let's take a look at the particular situation where we have one risky asset and one risk-free asset. And so there's two assets in the portfolio, the risky asset and the risk-free asset. So with that, the expected return on the portfolio is going to be equal to the weight on the risky asset times the expected return for the risky asset, plus the weight on the risk-free asset times the risk-free rate of return. We typically don't say expected return on the risk-free asset because it's a known return, okay? There's only one thing that can happen with it, okay? Remember, our definition of risk is anytime more things can happen than will happen. With the risk-free asset, there's only one thing that can happen, and that is what will happen. But what we're going to do is it's going to be very helpful for us to get rid of one of the variables. So we're going to take advantage of the fact that we know the weight on the risky asset plus the weight on the risk-free asset equals 1. So therefore, we can say the weight on the risk-free asset is going to be equal to 1 minus the weight on the risky asset, right? Weight on the risky asset plus the weight on the risk-free asset equals 1. So the weight on the risk-free asset is 1 minus the weight on the risky asset. So instead of saying W sub risky for the weight on the risky asset, we'll just say W, because that's, we don't need to have a weight on risky, weight on risk-free anymore. What we end up with now is going to say that when we have a risky asset and a risk-free asset, and we're going to call this equation number 1, because we're going to be referring back to it later on, we're going to say that the expected return on that portfolio, and again, this only applies when you have one risky asset and one risk-free asset. Equation 1 only applies in this case. The expected return of the portfolio is the weight, W is the weight on the risky asset, times the expected return of the risky asset, plus 1 minus the weight on the risky asset, which is the weight on the risk-free asset, times the risk-free rate of return. Okay, so equation number 1 applies when we have a risky asset and a risk-free asset. One risky asset, risk-free asset. Generically, okay, what we showed earlier, this all applies there. Okay, so that's going to apply in all situations. Equation number 1 is the specific situation where you have one risky asset and one risk-free asset. You can do a little bit of algebra to equation number 1, rearrange it a little bit and get equation 1a. Equation 1a says that the expected return on a portfolio. And again, this is only when we have a risky asset and a risk-free asset, is going to be equal to a base rate of return. That base rate of return is the risk-free rate plus a risk premium. Remember, we talked about this before. A risk premium is an extra return that you get for taking on a level of risk. So the risk premium, okay, here is going to be this part right there. The risk premium for our portfolio is going to be the weight on the risky asset multiplied by the risk premium for the risky asset. The risk premium for the risky asset is going to be this right here. The expected return on the risky asset minus the risk-free rate. That's the extra return that the risky asset gets above the risk-free rate. That's the risk premium on the risky asset. Multiply that by the weight on the risky asset. That's the risk premium for the portfolio, where the portfolio is one risky asset and the risk-free asset. So the expected return for our portfolio is this risk-free rate of return plus the risk premium, which is the weight on the risky asset times the risk premium for the risky asset. And you can take a look at this right here. And if you want to do the math, you can see that algebraically it's equivalent to this. Okay, you can just rearrange it a little bit and you'll be able to get 1A. So equation 1 and 1A are both giving us the expected return for our portfolio, but it's just sometimes it'll be a little bit more helpful to use equation 1. Sometimes it'll be a little bit more helpful to use equation 1A. Now, the next thing we've got to do is we've got to come up with the standard deviation of the portfolio. And that's going to be equation number 2 here. The standard deviation of our portfolio when we have one risky asset and one risk-free asset is going to be standard deviation of the portfolio is the weight on the risky asset times the standard deviation of the risky asset. And again, I want to emphasize this only applies when we have one risky asset and one risk-free asset. Let's see why this, when we have a risky asset and a risk-free asset, it simplifies so much that the standard deviation of the portfolio is simply the weight on the risky asset times the standard deviation of the risky asset. And we can do this by going and taking a look at the, on the whiteboard. So let me pull the whiteboard up. Okay, and if you recall, when we want to find the standard deviation of a portfolio, or let's start first, when we want to find the variance of a portfolio, we want to add up all the cells in its weighted variance covariance matrix. We talked about that before. So if I have a risky asset and a risk-free asset, I have a 2x2 weighted variance covariance matrix. I have a risky asset and I have a risk-free asset. So those are my two columns, my two rows here for the risky asset and the risk-free asset. And so in this upper left-hand cell, I want the variance of the risky asset, okay? And in my bottom right-hand cell, I want the variance of the risk-free asset. In my upper right-hand cell, I want the covariance between the risky asset and the risk-free asset. And the bottom left-hand cell, I want the covariance between the risky and the risk-free asset. And then I'm also going to put the weights in just a little bit. But we're going to simplify things a whole lot here. First of all, I think you know that the variance of the risk-free asset is 0. So if I have to add up these 4 cells to get the variance of my portfolio, we've just simplified things a little bit because this cell is 0. So now we only have to add up these 3 cells, but we're going to simplify things even more. The covariance between a risk-free asset, or I should say between the risk-free asset and any other asset, is also 0. Remember, if 2 assets are moving up together like this, that's a positive covariance. If they move up and down like this, that's a negative covariance. Well, remember, the risk-free asset, it doesn't move at all. So if my risky asset is going up and down while the risk-free asset stays still, their covariance is 0. If you look at the math on this, you'll also be able to see it's 0, okay? And we can also remember that the covariance between two assets is their correlation times the standard deviation of one times the standard deviation of the other. That also shows that the covariance has to be 0. So the covariance between the risky asset and the risk-free asset is 0. So adding up these 4 cells got really easy. This cell was 0, this cell is 0, and this cell is 0. Okay, so what's left is what's in this cell. Now, the one thing we haven't put in here yet is we want the weight on the risky asset squared. That is now a weighted variance covariance matrix. Remember, if you add up the cells in a weighted variance covariance matrix, you get the variance of the portfolio. So we're going to say that the variance of this portfolio is going to be equal to just what's in the upper left-hand cell, which is the weight on the risky asset squared times the variance of the risky asset. Well, if I want to find the standard deviation of the portfolio, all I have to do is take the square root of each side, and that becomes really easy. The standard deviation of the portfolio is equal to the weight on the risky asset times the standard deviation of the risky asset. And we're calling that equation number 2 because we're going to refer to it later on. And again, this only applies, this equation number 2 only applies when we have one risky asset and one risk-free asset. Okay, and we can see now why it applies. And that's going to make life a little bit easier for us because it means that standard deviation is going to be linear between that risky asset and the risk-free asset there. So let's go back to the notes here again. Let me pull them back up. Okay, and so we saw that equation number 2 here is that the standard deviation of the portfolio is the weight on the risky asset times the standard deviation of the risky asset. Now, when we go back to our 2 assets that we had that we looked at last time, remember asset number 1 was the risk-free asset, and it had a standard deviation of 0, and it had an expected return of 5%. And we also saw that asset number 2, the risky asset, had an expected return of 22% and a standard deviation of 34.29%. So that's what we've got right here, okay? Our risky asset, okay, has a standard deviation of 34.29%. Our risk-free rate of return was 5%. Our risky asset has an expected return of 22%. What we're going to do, we're going to say, let's put 60% of our money into the risky asset and 40% of our money into the risk-free asset. Remember, our weights have to add up to 1, so that's what we're going to do. So this is going to be, W is going to be the weight on the risky asset. 1 minus W is going to be the weight on the risk-free asset because the weights have to add up to 1. So this is going to be our situation here when we put 60% of our money into the risky asset and 40% of our money into the risk-free asset. So now if I want to find the expected return on my portfolio, it's going to be 0.6 times 22% plus 0.4 times 5%, which is 15.2%. That was using equation number 1, which is the weight on the risky asset times the expected return on the risky asset plus the weight on the risk-free asset. 1 minus the weight on the risky asset is the weight on the risk-free asset times the risk-free rate of return. Or we can use equation number 1A. I didn't here, but we can use that. That would work out as well. Equation number 2 is going to give us the standard deviation of the portfolio. And that is 0.6, which is going to be the weight on the risky asset times 34.29%, which is the standard deviation of the risky asset, gives us 20.57%. So that's going to be the standard deviation of the portfolio. So let's take a look at our whiteboard here, okay, and bring this back up. Okay, and let me clear this out here. Okay, and we're going to go into mean variance space, which means on my y-axis, I have expected return. On my on my x-axis, I have standard deviation. Here is my risky asset right there. Here is my risk-free asset. My risky asset has an expected return of 22%. standard deviation of 34.29%. My risk-free asset right here, R sub F, has a 5% return. If I put 60% of my money into my risky asset, 40% of my money into my risk-free asset, my 60-40 combination is going to be right about right there. I don't draw real well. I can't guarantee that's exactly the right spot. But the expected return on that we just calculated, and the expected return on that is going to be 15.2%. So that's 15.2%. And the standard deviation here is going to be 20.57%. 20.57%. So really, I mean, you can think of it, the 20.57% is 60% of the way over to the standard deviation of the risky asset, which was 34.29%. And the 15.2% means that 60% of the risk premium on the risky asset is given to this portfolio. So here's the risk premium on the risky asset. It goes here from the risk-free rate up to the expected return on the risky asset. That is the risk premium on the risky asset. The risk premium on the portfolio is 60% of that, because I've got 60% of my money into the risky asset. So from 5% up to 15.2%, that is the risk premium on the portfolio there, all right? So now let's take a look at our investor that has utility of 3, and has an A of 3, or coefficient of risk aversion of 3, and let's see how much utility that investor gets from this particular combination of the risky asset and the risk-free asset. Remember that our utility is equal to our expected return minus 1/2 times A, the coefficient of risk aversion, times the standard deviation of the investment squared. Now, this portfolio here has an expected return of 15.2%. It has a standard deviation of 20.57%. So, and this person had an A, we said, of 3. That was their coefficient of risk aversion. So we take 20.57% squared, multiply that by 3, multiply that by 1/2, take that quantity and subtract it from 15.2%. And that will give us the level of utility our investor gets from this portfolio. And that's going to be equal to 8.85%. Now, you recall from our last video that this investor with an A of 3 got 5% utility from the risk-free asset, 4.36, I don't remember, 4 point something percent from the risky investment. But now we find that they get 8.85% from this portfolio. So clearly, they're going to prefer this portfolio above either the risky investment or the risk-free investment. So their indifference curves are going to look kind of like this. This is going to come through, and it comes down there like this. This is going to come up here like this, and this is going to come through something like this. And this indifference curve that goes through the portfolio is going to hit the y-axis at 8.85%. And remember, our investors always want to go northwest to get more utility. So our investor with an A of 3 is going to prefer this combination of the risky and risk-free investment. Now, that's not always going to be the case, where an investor is always going to prefer a portfolio over either the risky or risk-free investment. It depends upon what their A is, and it depends upon what the particular combination is. Okay, but in this particular case, that's what they are going to prefer. So we have seen now with equation 1, 1A, and 2, how to find the expected return on a portfolio that has one risky asset and one risk-free asset, and how to find the standard deviation of that portfolio as well. And we now can see how to find the utility that an investor gets from that portfolio. And of course, our investor will choose, if they have the choice of the risky asset, the risk-free asset, or the portfolio, will choose whatever gives him or her the highest level of utility. Okay. We will return to this one risky and risk-free investment in the next video.